What does it really mean for an AI to think? Today, we're diving deep into the .NET behavioral imperative. Behavioral answers now define .NET hiring outcomes. The interview has evolved from cultural fit check to a rigorous assessment of engineering judgment under the .NET runtime. Interviewers parse stories for evidence of concurrency handling, memory awareness, and platform-specific decision-making. Candidates relying on generic star frameworks miss the opportunity to signal technical depth, producing false negatives at the senior level. Interview.net behavioral questions closes this gap by mapping .NET competency domains to narrative structures that resonate with technical panels. Visual.net competency wheel, async memory DI testing, deployment overlaid on behavioral answer pipeline. But here's where it gets interesting. The Guerenic star CIling generic behavioral preparation treats all roles identically, ignoring the runtime context that defines .NET engineering. In a .NET interview, action without technical specificity is noise. Panels ask, how did you leverage async await to improve throughput? Generic actions fail to answer. The result, 2 out of 3 senior .NET candidates are rejected for lack of technical storytelling, not lack of skill. Existing prep tools provide no bridge between behavioral competencies and platform architecture. Visual side-by-side comparison, generic star answer versus empty .NET calibrated answer space. So what's the real problem? Let's talk about the competency context disconnect. Behavioral rubrics evaluate communication, leadership, problem-solving agnostic of stack. .NET engineers make thousands of micro decisions driven by the CLR, task schedulers, and DI containers. When stories omit these decisions, they erase the engineering signal evaluators are trained to detect. The cause is not poor storytelling, it's a missing translation layer from technical action to behavioral evidence. This disconnect is most acute in cloud-native .NET roles where infrastructure decisions are inseparable from behavior. This translation layer is the core of interview.net. Behavioral questions, visual 2 columns behavioral competency, communication, ownership versus .NET execution artifacts, GC pressure, middleware pipeline with a gap. This raises a critical question. Engineering competency as narrative. The breakthrough, map every behavioral competency to a .NET specific manifestation. For conflict resolution, the manifestation is navigating a pull request, a debate over task versus value task. For ownership, it's monitoring memory dumps and optimizing GC in production. This mapping creates a narrative framework where each star component is backed by a .NET artifact, converting interviews into demonstrations of technical leadership. Visual transformation abstract competency vague story, competency plus .NET, artifact signal rich narrative. Now let's zoom in on the interview.NET behavioral framework, a systematic architecture with 3 layers, competency mapping, artifact attachment, narrative composition, competency mapping, 8 core .NET engineering behaviors cross-referenced with 24 behavioral question archetypes, artifact attachment. Every story action must link to a concrete .NET implementation detail, Campbell case, memory profiling, DI lifetime choice, narrative composition, structured templates embed technical rationale into the star sequence, creating the .NET star narrative. The framework adapts across .NET 6, 7, 8, and .NET 9 with version-specific artifacts, visual, layered architecture, competency layer, artifact layer, composition layer. Here's something most people overlook. Core competency modules, 8 modules bridge technical tasks to behavioral competencies like ownership and conflict resolution, async contrigaines, task scheduling, ConfigureAwait, deadlock avoidance, concurrency conflict resolution, memory subperformance, span date, array pool, memory dumps, DI and architecture, lifetime scoping, keyed services. middleware pipelines, error handling, policies, exception middleware, result patterns, testing, XUnit, mocking frameworks, integration tests with test containers, CI/CD, YAML pipelines, containerization, blue-green deployments, code review, PR feedback loops, design pattern negotiation, API contract review, production ownership, monitoring, dump analysis, incident post-mortems. Each module directly maps to behavioral question archetypes like tell me about a time you resolved a production incident, visual icon grid of 8 modules connected to question type tags. Think about this for a second. The .NET Star workflow. Answer construction follows a pipeline, situation, task, action. .NET reasoning, result, situation, and task frame the context with .NET specifics in our ASP.NET Core 8 API handling 2K RPS action. Describe the technical steps and the .NET artifact wielded introduced a channeled pipeline with bounded capacity and backpressure. .NET reasoning state why the approach was chosen, used value task for low allocation async returns to reduce GC pressure. Visual pipeline diagram situation task action .NET reasoning result. And this is where things get complex. Artifact mapping matrix. For each competency, the framework provides curated .NET artifacts that signal depth, ownership, GC dump analysis, application insights, alerts, retry policies, collaboration, API contract review, middleware negotiation, OpenAPI spec alignment, debugging, memory profiler, WinDBG sessions, structured log correlation. The matrix ensures every story contains at least one platform-specific anchor, turning soft skill narratives into technical leadership evidence. Visual matrix grid competency columns, .NET artifact rows, check marks. But here's where it gets interesting. Integrated rehearsal engine. The platform evaluates answers in real time, checking .NET artifact density, a star completeness, and technical accuracy. It flags missing platform context. Your action didn't mention how you handled thread safety. Provides calibrated .NET follow-up questions that interviewers typically ask after a behavioral response. Candidates iterate, seeing technical signal score improvements with each revision, transforming prep from memorization to deliberate architecture. Grounded practice, visual dashboard answer input real-time score, .NET signal meter improvement suggestions. So what's the real problem? Let's talk about signal conversion impact. Candidates using the framework saw a